All right. Good morning. It is March 19th. And so, yeah, that puts us right here in our calendar. So, yeah, just, I guess, a reminder that there's nothing technically due this weekend. Tutorial 5 is due next weekend. It is largely templates and I think operator overloading as well. And then, one sort of minor class function from your assignment. Assignment 4 also been pushed back a week. It is due on April 5th, right? So technically, to finish it, you need templates, which we'll do next week, and then you need files and streams. I'll move up. Although, so there is a part where you have to read from a file. You can, feel free to try and research that on your own if you get impatient. It's not super difficult stuff. There are a couple gotchas, of course, which I'll show you, but yeah, nothing too difficult. So that's where we stand at the moment. Yeah, I guess I should, I'm going to find out when, I'm going to find out the status of assignment 3, I suppose. Test 2, they are just starting to mark. Yeah, any questions? Okay, so we are going to continue today with operator overloading. Now, this is a bit of a, it's a bit of a technical slog. If you don't like all the technical details of C++, then I apologize for this lecture, but that's where we're going today. So last class, we had talked about operator overloading for the stream insertion, and apparently I saved these red marks on my PDF. So we just have to put up with them, I guess, for now. So we have this operator that we can overload for streams, right? And so the idea is that now we are going to do that for our classes instead of using a print function, or instead of just using a print function. So we want to overload this stream insertion operator. The drawback to that, or one of the drawbacks, is that we have to do this as a global function, all right? Because the left-hand side operand is an OStream object, which we don't have access to. So we cannot add a function to the OStream class, and adding it to the time class doesn't make sense because it's always the left-hand side operand. That would be this. So we have to add it as a global function, which means that we lose polymorphism. Because we can't really have polymorphism as a global function. Oh, I guess I can erase these. All right, sweet. You can't make a polymorphic global function, right? It doesn't make sense. There's no underlying object there. It's just a function. So how do we print? So now we want to print using this operator. So how do we do it if we have a class hierarchy? And so we had started looking at that. Incidentally, I'm going to try Sublime. It's just another text editor. I'm going to give it a try. I don't know. Visual Studio Code has been, I guess, I don't know. I don't want to say annoying, but I just feel like a change, I guess. So where we left off, we had an animal as a base class, and we had a bird that inherited from animal, and we had a chicken that inherited from bird. And previously, the print function was virtual. So if we had an animal pointer pointing at a chicken, let's say, and then we called print on the chicken, then the chicken would say cluck, cluck. Or maybe there should be a speak function, but you get the idea. So we have polymorphism, but now we want to, instead of a print function, we want to use this. And so we wrote one. We made a friend, we wrote one for animal, but then as we saw, like when we tried to print a chicken, a bird, either using their own handles or using animal pointers. Let me just fix that. First of all, there are multiple problems. I'm using cout instead of the proper stream. And then I want to return that. So yeah, now every time we print or try to print by throwing it at the standard output, a bird or a chicken, it just prints like an animal. Okay, so well, we can do something like this. Let's say that we make a special one for birds. Bird says tweet, tweet. Okay, and then we need to make that a friend of our bird class, right? Because friendship, well, first of all, this is a completely different function, but regardless, yeah, it's not, we don't get any friendship for free. We have to declare it explicitly. So now when I run this, well, my bird says tweet, that is this line here. So when I use a bird handle, it works just fine. When I use my animal handles, well, I still get the animal behavior. So I'm not getting this polymorphic effect that I really want. So the solution is, right, so hopefully everybody understands, I want this bird to tweet. I want this chicken to say cluck, cluck. I want this bird to tweet down here and this chicken to say cluck, cluck. Well, the solution is that we just use this one, but then we call a polymorphic function in here. So we're going to say a.print. But print currently just prints to C out, and we want to generalize this to print to any stream, right? Because maybe we're printing to a file or something like that. So yeah, we're going to get rid of this. And then, yeah. So that's the one thing about Sublime. I have bought a license. I need to remember my password, but yeah, it's free if you don't mind being reminded every once in a while that, hey, you should buy this. So I'm going to adapt my print function to now take a specific stream. So now I can print to cout if I like, or I can print to a file. And in particular, I can just use the stream insertion operator to send my animal to that stream, and then have that call the print function and pass in this particular stream, right? So this I do not get polymorphism, but the print function I do. So inside my global function, I call a member function that is polymorphic. All right, and then we want to add these to our new print function. And I'm just going to, not that it's a big deal and not that you would lose marks or anything like that, but I am going to change this to use override rather than void, because it is a little safer. That's actually, Okay, so now when I run this, my bird says tweet here, my chicken says cluck, cluck. That's where I'm just using the correct handles for those animals. But even when I use animal pointers to point to my chicken and to my bird, I still get that polymorphic behavior. Okay, so it's a tiny little pattern that we use for inheritance hierarchies when we want sort of this polymorphic print. Questions? Okay. All right, so we're going to look at a couple more operators in particular. And again, the focus is on when we overload this operator, right? So what are the arguments? What should we return? Should we return by value or by reference? And so we're going to focus on these two operations. One is this. So this will add C and A together and then store the result in C. And then also we should be able to combine that with other expressions. So this should return something, and in particular, it should return the modified value for C, or just C itself. Here, we want to do something similar. We want to add A and B, but we don't want to store it in either A or B, right? A or B should remain unchanged. But we want to return that new value. So we're going to make, in this function, I'm going to make a temporary variable. And now there are rules for temporary variables when you return them. And in particular, the rule is you have to return by value, right? Because, well, we'll try it by reference and you'll see. All right. Okay, so we want, we're going to make a lunch at 12 noon, and then we're going to add 80 to it. We'll say it's 80 seconds, and then print it out again. Here, let's just do these two lines first. So we want to overload this this plus equals function, and we know that we should be able to embed it in other expressions, which means we want to return something. We want to return a time object, and when in doubt, we're going to return by reference. Okay, and then we will add another time object to that. And this will not be const because the whole purpose is to actually change the value. And then I will implement it here. Okay. Oh, sorry, this should be an int, right? Yeah, sorry, this is an int. Int t, although there's nothing stopping us from overloading this function, but let's write the one that we're actually testing. Okay, well, simple enough. I want int temp time, or let's call it new time, equals convert to seconds plus t. Right, so I'm going to convert my current time to seconds. I'm going to add this number of seconds to it. That will be my new time, and then I'm going to use the set time function here to convert that into hours, minutes, and seconds. Right, and then when I'm done, I'm going to return the current time object by reference. Okay, so that should allow us to print out lunch, which is 12 noon, and then add 80 seconds to it. So this should print out 12:01:20. Oh, wrong one. All right. So. Okay, so lunch before I add 80 seconds to it is 12, and then once I add 80 seconds, it's 12:01:20. And we also, of course, want to be able to embed it in other expressions. So if I add another 20 seconds here, this should print 12:01:40, and then also down here 12:01:40, right? So just to verify that I am actually modifying that that lunch object, unlike before where we were used cascading and we returned by value and or chaining. And we returned by value, and it didn't actually modify the lunch object, right? So 12:01:40. So everything looks good with plus equals. Questions? Okay, let's jump into the next example where we're going to, well, we're gonna shut this down, and then so I'm going to make a time called I go home, which is 1:15, and then you go home. Well, this is just going to give us default values. So if we print those out, I go home before 1:15, you go home before, well, you don't have a value yet. Okay. So what we want to do is we want to be able to take when I go home, and you're going to go home an hour later. Right, so 3,600 seconds is an hour. So we want this operation to work essentially, which means we're going to have to overload this plus operator. And so should we overload it as a member function or a global function? I know it's early. It's early. I surprised you with that question, but. So what should we consider when we're considering whether to make it a member function or a global function? Yeah. Yeah. So we want to look at what comes first or the left-hand side operand, right? So, and here it's an int. If it was a time object And really we should write both versions of this because plus is, what is it, commutative or associative? I can't remember. I don't know. It's one of them where, so you can, whether you add 1 plus 2 or 2 plus 1, you get the same answer, right? Whatever the word that happens to be. I'm not sure. So we want to write both, but in particular, well, we're going to write this one, right? This is the more difficult one. The left-hand side operand is an int, which means we have to make it a global function. If it was a time object, we could make it a member function. Commutative, thank you. I have to think very carefully whenever I use those words. All right, so this is plus. Now again, we're going to, normally we would return by reference, but in the plus operation, we're going to make a temporary time object and return that because we do not actually want to modify either of the operands, right? So we're going to return by value here. So return by reference, unless you're sure you should return by value, well, we're sure. The left-hand side operand is an int. The right-hand side operand is a time object. There is no const here. Const makes no sense for a global function. And then to implement that, we're going to put it in time.cc. Okay. So what we want to do is we want to add, well, T2 is a time object and T1 is an int, but we know how to add those together. So we're going to, well, time temp. We're going to make a temporary time object that we're going to store these values in later. Int, summed time. That's a terrible variable name, but we'll go with it. T1 plus T2 dot convert to seconds. Okay, so now I have this new time summed up in seconds, and then I'm going to set the temp time to the summed time. Okay, so that's it. We've added T1 and T2, and we've stored the result in this temporary object. We want to return that temporary object. If we return by reference, the compiler is going to complain, and if we try to access that return variable, we would likely get a seg fault. If we didn't get a seg fault, that would be even worse, because then we did something, we accessed memory that we weren't supposed to, and that can lead to all kinds of problems. So here we're gonna return by value, right? So we already, I believe we went over that in some previous examples. All right, so this should work now, and I should be able to print these guys out. So I go home after 1:15, and you go home after 14:15. So here we return that temporary time object, and it got assigned using the assignment operator to this time variable. Okay, so that's it. So plus equals, you want to return by reference. Addition, you want to make a temporary object, return by value. In general, that's basically the heart of the lesson for this one, but questions? Okay, well, there's another example here. Might as well finish it off. So what if we want to add I go home plus you go home together, which kind of maybe makes sense. So we're going to make an addition function, but now it both left-hand side operand and right-hand side operand is a time object, which means we can make it a member function. We still want to return by value. And yeah, we can make this const as well. And we're going to largely do the same thing here that we did up there. So we're going to make a temp time object. We're going to sum, instead of T2 dot convert to seconds, that's just going to be, well, if we're going to be explicit, we can put this, or we could just leave it as convert to seconds. Set the time to the summed time, return temp. So that should work there. So does it really make sense to add 2 times? Well, I don't know, but we're going to do it anyway. So this should sum up to, well, this is 1314 or 1315. This is 1415. So this should be like 2730. Oh, wait, I did something wrong. No known conversion. Right. Yes, you're right. Incidentally, I don't know if it was brought up here. It was brought up in 2 of my sections, right? And they both made this argument that I can make a conversion constructor here, which is actually would probably work. There are reasons to do it and reasons why that might be a bad idea, but you know, those are all context dependent. I believe that would work just fine. That's not the solution that we're going to go to, and I unfortunately don't think we have time to try it out, but yeah, it was I like that's good thinking. I guess I didn't save that. And yeah, that's the kind of thinking that, you know, makes for a good C++ programmer. No, we did not do any woo claps. In fact, the other 2 sections, we did not get to the woo clap. We might. It was very close. So the other 2 sections, we're going to do the woo clap in the beginning of next class. And this one, I'm not sure. We may not get to it. So you go home and I go home. If I add them together, I get 2730, which, you know, if you do the math, that makes sense. Okay, one last thing. Right, so I want to overload the assignment operator, so I can just assign an integer to my time object, and I'll convert that into a time object. And Tuesday's woo clap. What did we do before this? No, so Tuesday's woo clap was I did not have a woo clap for design patterns, and so I have a woo clap for operator overloading, but operator overloading is really long. It takes 2 lectures essentially. So yeah, last class we did not do a woo clap either. So yeah. There's a few more I could definitely insert in there, but there is a woo clap coming up, I promise. Okay, if we try to make, well, oddly enough, it compiles. And so I'm concerned with this line here. So I said you go home equals 60. And what I want is that to be like 1 minute after midnight. What I get is 0. I also got a call to the constructor here, which is interesting, instead of the assignment operator. And here I tried to do the same thing. I said you go home equals 80. And instead I got 0 with a call to the constructor. So yeah, what is happening here? We looked at that a few lectures ago, but right. So the assignment operator is not actually getting called. What's happening is the compiler is doing its tricks, and it's saying, well, I want to take this and convert it to a time object and then assign it to here. And so it says, well, is there any way to convert a single int into a time object? And it looks at our constructor and says, well, yeah, I can use a single int as an argument. These 2 have default values. So that will create a time object based on passing in the first parameter. And we pass in 60. And if we look at, you know, the constructor we call set time, And hour is equal to 60, but of course 60 is out of bounds. It's not between 0 and 24, so we set it to 0. So that's what's happening here, is that we are doing an implicit conversion, right? That's why I said, for those of you who mentioned that, why don't we just use the implicit conversion in the plus operator? And yeah, that would probably work. It certainly works here. But that's not the behavior we want for this. We want actually that to fail. So when we write explicit, now it no longer does that implicit. And now we can write an operator. I'm just going to write really quickly because don't have a ton of time. Yeah. In fact, I'm going to cheat even more. I'm just going to write this implementation into the header. Set time t. Return this. Okay, so that should be able to set you go home to 60 seconds, so 1 minute after midnight, and then 1 minute and 20 seconds after midnight. And so here, you go home 60 after midnight is 1 minute, and you go home 80 after midnight is 1:20. All right, questions? Yeah? Yes, exactly. That also rules out yeah, if I did something like this, I believe it would also complain. Let's try it. No. Hmm. Well, color me surprised. Yes, with the caveat that I guess I don't completely understand where all the cases are. So yes, that should eliminate implicit conversions. There's some detail I'm missing here, though. I'm sorry. Yeah, it's not behaving the way that I expected. But yeah, stuff like this, where or here, if I didn't write this function, but I had one for 2 time objects, then it would convert this to a time object. All right. Other questions? Okay. All right. So this just explains all the things that we did. You might be tempted, so we're returning time objects either by reference or by value, so they can be embedded in other expressions. We might be tempted to just return an int, right? Since we can sort of represent a time object as an int. But then, of course, if we do that, then this expression will not work, and we kind of want that to work, right? So if I take time and add 80 to it and then call print, that should work. If I return an int, it won't. So always sort of do the extra work and make a new object. So now we're going to talk a little bit about collection classes. We'll quickly touch on the, of course, there's a lot of extra considerations. What does it mean for 2 collection classes to be equal? Do they have to be the same size? Do they hold all the same elements? You kind of have to make some decisions. We will get to vector, and we'll talk about how vector decided to do it, and how vector decided to do it is just matching up the contents in their positions, and it doesn't really worry about the size of the backing array. But there is an important lesson here for this subscript operator, which is one of the things I want to focus on. So we have a book class, which we've seen before. We've added this not equals operator, which just checks to see If the title is not equal to the title or the author is not equal to the author, then they are not equal. If both of those match, then it will return false. All right, so we just want to check to see if these two are distinct books. And now we want to make a book array. Now, it's not very complicated what we want to do. Really, what we want to do is we want to have a very light wrapper around an array. Simply so that we can do, right, if we just use a raw array and we use the wrong index, then we're going to read into memory that doesn't belong to us. So we just want to do a bounds check. That's basically it. Otherwise, we want to implement basic array functionality and maybe a couple other stuff, a couple other things. Okay, but we're going to start with this subscript operator. Well, actually, let's see how this should behave. So I'm going to make a bunch of books. And for starters, I'll print out a couple just so we can see what it looks like. And then I want this book array, I want to be able to assign each of those books to a pre-existing position. Okay, so our book array class has a backing array. It's a statically allocated array of book objects of size capacity. So very simple, fixed size, all objects. And so when I do this, it should copy B1 into the first array location and B2 into the second array location, etc. And then we could print those out. We'll start by doing this, and then we will implement this operator. Go to here. All right. And then these print pretty wide. But there we go. So Ender's Game and Dune are books B1 and B2. Okay, so now we want to copy those into our book array, and then we're going to write out those same books, but now from the book array. Okay, so to do that, we're going to overload this operator. And it's so simple. We want it to return a book, right? When in doubt, return by reference, so that's going to be fine. It is the subscript operator. It takes a single a single parameter, in this case an int. Although somebody asked, can you make this a string? And it turns out you can if you like. So you can actually you can overload this operator to make like a dictionary, like you would find in Python, which I thought was kind of cool. And then all we want to do is we want to return the book at that index, but only if the index is valid. Okay, so let's write that. Sure. So if index is less than 0 or index is greater than or equal to capacity, right? Then that's out of bounds, and well, we're going to do something. We haven't taken exceptions yet. But here's a little preview. We're just going to throw, and we're not even throwing an exception. We're just going to throw a string, right? So you can do stuff like this in C++. And what's going to happen is that if we try to access something out of bounds, this is going to crash, basically, which is what we want. Like, we don't want it to keep going, having silently corrupted our memory. If we try to access something outside of memory, we want to crash. If it's inside, if it's a valid index, we're going to return elements at that index. All right, really simple function. We're going to do this again on your assignment. You're going to do this with a templated class, right? And the templated class is slightly more complicated, but not really too bad. And I ask this on final exams all the time, as like sort of an easy question for anybody who's been paying attention, and you should see some of the answers I get. So yeah, know how to do this. It's really simple, but of course there's some fine details in there. All right. This should work now. So let's try it out. So printing from the book array, the same two books. Yes, there's a little bit extra formatting there. That's fine. We put that in. Okay. Good. Questions? Easy peasy, right? Okay, but there is sort of another twist to this. So what if I want to print out the entire array, the book array all at once? So I do have, I have overloaded, or at least I made it a friend of mine. And for now, this is commented out. So what I really wanted to do is the same thing as this print function. So let's do that. But I'm going to do things slightly differently. Instead of elements now, this should be ba.elements. And if I do that, it's going to work. Okay. But what I'm going to do is I'm going to say, well, what if I'm a little bit clever and I say, well, I don't even need to do that, right? I've overloaded already this operator. So I could just call on the operator directly, and that should work. Okay, so let's, well, it doesn't work. I got an error that I've discarded this qualifier, this const. Right, so what exactly is the problem here? Why doesn't this compile? Yeah. That's right. So this operator is just a function call, and it's not a const function, but I'm calling it on a const object. Okay, and so I've sort of contrived, like this is, I did this on purpose, but this does come up where I want to be able to return something, but I want to be able to return something on a const object. I just want to read it. I don't necessarily want to change it. Okay, well, I guess the simplest thing is to say, let's make this a const function. And well, if you know anything about const functions and return values, when I try to return that element, it says that, oh, you can't do that, right? And the reason, right? So if we look at this, now I've said const, I'm saying, well, I promise not to change anything in this book array. So none of the data, and in particular, even this location. There's a book in there, and I promise I'm not going to make any changes to it. But I'm returning that by reference. So that means anybody who grabs a reference to it, calls on this function, and then grabs the return value can actually modify that book. So I have to make a stronger promise. I have to say, well, I'm going to return a book by reference, but I promise that whoever grabs it has to store it in a const variable, and then they won't be able to change it. Okay, so we haven't talked a lot about return values, but I am technically returning something from inside my object, and I need to promise I'm not going to change that. Okay, so now, all right, well, now we got another error. We got a bunch of them where we're trying to assign these values because, oh yeah, now I've promised I won't change those, but I actually do need to change them. So what often happens when we want to make an operator, like a subscript operator, is that we probably need two versions of it, right? If we want it to work in every case, well, this const is part of the signature. So if I take that away, well, then I can have one version that works, right? So if I call it on a non-const object, then the compiler will call this version. Whereas on the other hand, if I do call this, use the subscript on a const object, then it works, but it's going to be read-only. Okay, so, and then in terms of implementation, well, they're exactly the same, except for this. Oops. And this applies to here. It's also, now that we're using const, like basically any sort of get at index sort of thing on a collection class, it might be a good idea to make two versions of it. It's not that you may not necessarily need two versions in your assignment, but it doesn't hurt, right? It's gonna make sure that you're prepared for every situation. So now, yes, we're able to assign those values, but also we're able to print them out off of a const object. All right, questions? Yep. Yes. Yes. So let's do that. I believe that'll work. The only difference is it's slightly less efficient, right? Because now we're making a copy, but I think yeah. So the idea is, of course, this is a const function, but if I return the book by value, then I'm not actually passing back the original, I'm passing back a copy. So, and that should work, I believe. What's wrong? Binding, I didn't save, right? No, I don't know. It's always a good question when it leads to an error. It's complaining about, yeah, sorry, somebody have an idea? Yeah. Yeah, I guess I would have expected it to, I mean, I can do, let me see. I can probably do this, which uh, it would surprise me if that were necessary. Oh, good grief. Book. Hmm. Oh, you know what? That may have been the problem all along, because I think it is. All right, so what did I do in here? So I don't even think I need to do this. The problem was that, well, let me make sure that it compiles before I start yapping about it. All right, so it works. So the problem was that I had overloaded this, or I overrode the copy constructor. So the default copy constructor looks like this, right? So if I relied on the default copy constructor, that would have gone through. But because I added a copy constructor, but I took away the const qualifier. Well, now there is no const qualifier copy constructor. So, so yeah, I was getting, the error was when it tried to copy that, it didn't have the proper copy constructor to copy a const object. So yeah, this should work now. Boy, oh boy, C++, there's so many like little corners that, that can trip you up. All right, so yeah, good idea. There is a small amount of overhead with that, but you know, if you're not super concerned about performance at this place, then you can absolutely do this. All right, questions? Okay. Well, as mentioned, you can overload stuff like the equals operator or the double equals. Let's do those very quickly. That's not what I wanted. just as sort of an honorable mention. All right, so if I want to copy, so now I want to assign this current book array with this book array, which in this case is kind of simple because, well, the backing arrays are the same size. So really I can just go through every element of this book array and copy it into my current book array using a for loop. And then, yeah, elements at I equals BA at I. Right, if in this case, so yeah, I'm just going through, I'm copying every single location. Now, the way we've made collection classes, of course, we have a huge backing array and maybe we only have a few elements. Like maybe we have a backing array of size 100 and just the first 10 locations have things in them. So now when we use the assignment operator, well, maybe we should only copy those 10 things. And then maybe we should change the size of the size variable, right? So our size variable says 10. And so with the array that we're copying into, we should maybe change the size variable to 10 as well, right? So there's a lot more considerations when you overload these operators for collection classes. This double equals, which we can also write really quickly. Well, same thing. I have to decide what it means for two things to be equal. So in this case, they're very simple. They all have size 4, but maybe, again, I have the big backing array and I have, the first 10 locations. So maybe for these two array or collection classes to be equal, I need to make sure the size is the same first. And then I want to go through and check each individual element to make sure that whatever's in location 1 in the first array is in the same, is also in location 1 in the other array. So here this is a very simplified version, but we'll say if elements at I is not equal to BA at I, right? So if we go through and there's at least one book that does not match, then we are going to return false. It should be Boolean. And if we get through and all of the elements match, then we're going to return true. Okay. And again, this is a very, very simple collection class. Typically, there would be a lot more things to consider. But now we can do stuff like this. I can make a book array 2. I can print it out initially, so it's just going to get all default values. I'm going to assign book array 1 to book array 2. And then I'm going to print it again. And then I'm going to ask if these two things are equal. And let's ask that twice. Yeah, I forgot to return this, but it'll be fine. P8. So book array 2 just gets all default values, so unknown books by unknown authors. And then when I check to see if it's equal to array 1, it says no. And then I use the assignment operator on array 2, and now it has all the same values as array 1. And when I check to see if they're equal, it says yes. Okay, so collection classes, of course, now we have to, there's a lot more considerations, essentially. Questions? Okay, how are we doing? Half an hour. Oops. Okay. So we're going to take prefix and postfix, increment and decrement, all right? And there are a lot of ways that we can implement them. So we can implement them as global functions, of course. That doesn't mean we should. I think typically you would implement them as member functions, but we're going to show you how to do both ways. And we're going to show you sort of the subtle difference between these two things, right? Whether I do ++I or I++ actually does make a difference. So the general rule of thumb when we're doing the increment and decrement, we're going to do it again on the time class. The general rule of thumb is it should behave the same as an integer. So we're going to use this int, we're going to use prefix and postfix operators on it, and then we're going to use prefix and postfix operators on our time class, and we're going to make sure that sort of the behavior matches up. Okay, so we're going to start with an int called 10 with value 10, and a time object now that's, well, that's not now, but close enough. Here, let's make it now. 9:25 and 55 seconds, let's say. Okay, so the original int is 10, the original time is 9:25:55. Now, what's the behavior for a prefix increment on my int? Well, it's going to increment it. Well, let's run it, see. So it increments it from 10 to 11 and then returns the new value, right? So actually the prefix is simple. We just bump it up one and then return itself. So that's what we're going to do with our time class. We're going to do this as a member function. Now, I should be able to embed it in other expressions, which means, again, I want to return something, a time object, and I'm going to return it by reference. Right? We return by value if we make a temporary object and return it, but in this case, I'm going to return this, which I can do by reference. The operator is plus plus, takes no operands. It cannot be const because we are actually making changes. And well, for the plus plus, we're going to add a minute, right? So we're going to add 60 seconds. So I'm going to say int new time equals convert to seconds plus 60, set time to new time, and return this so that it can be used in the next expression. Okay. Let's see if this works. Okay, so here we went from 10 to 11, and 11 was printed twice. Here we went from 9:25:55 to 9:26:55, and it was also printed twice. So we are getting basically the same behavior. So yeah, that seems to work so far. Questions? Okay. Well, now we're going to overload it as we're going to do the decrement, but we're going to overload it as a global function. Now again, the behavior is quite simple. I'm going to decrement from 11 to 10 and then return that new value, right? So both in this expression and when I print it after, I get the same result. Been forwarded to voicemail. And I want this to do that as well. Your call has been forwarded to voicemail. All right. Somebody was watching on their phone, I think. Okay. So I want this to be overloaded as a global function. So I want it to be a friend of mine. I'm going to return, again, a time object. The operator is minus minus. But now I have to explicitly pass in the parameter. So right, there's only one operand, and it has to be explicitly passed in. And then I can write this. And it's largely going to look the same as this. So I want t.convert to seconds, but instead of adding a minute, I'm going to subtract a minute. And then instead of returning this, I'm going to return t. Okay. Ugh. It's private. It doesn't have to be global. I'm just doing it to demonstrate, right? You should make it a member function typically. I'm just doing it to demonstrate. Oh, that was a sneaky one. I'm just doing to demonstrate how to do it, in case you ever see it. But I would say the best practice would be to make it a member function. Still, not declared new time. Yes, that's what I'd. T dot set time. Okay, so we went here from 11 to 10, and then we went from 9:26 to 9:25 and printed twice. So great. That's the behavior we want. All right, moving along to postfix. So now we're going to see what the difference is between prefix and postfix. And in particular, let's look at what the output is for our int. Okay, so now we have two different values. So what happened here was, well, this was 10. I wanted to increment it to 11, which I did, but I returned the old value of 10. Right? So the postfix means like, I want that, I use that value, and then after I want to increment it, so to speak. Of course, that's not how things work. We're going to have to make a copy of the old value, and then we're going to have to increment it, and then we're going to return the copy. All right, so that's what happened here, which means there's a few extra steps, or at least one extra step. I have to make a temporary time object. So let's do that. Now I'm going to make a temporary time object and return it with the old time, even as I increment the new time, which means I'm returning a temporary object. I want to return by value. Well, this might cause a problem because those two things have the same function signature, right? The return type is different, but as far as the compiler is concerned, that does not factor into it because I can always just ignore the return type. So the people who made C++ needed a way to tell the compiler that this one is a prefix and this one is a postfix. And I mean, I can think of at least 100 ways to do it that are, I would argue, better than this. But what they did was they introduced a dummy parameter, right? So when you overload a function, if you have different arguments, of course, then you have a different function. So I mean, I don't know. I don't get it. You could always just like add like a P here or something, but anyway. They did the dummy parameter, so it is an int. You can use it, but you don't have to. I don't know. It's probably not initialized to anything, but it does exist. So return by value, dummy parameter, so that the compiler can tell it apart. This is my new time, but I want to copy the old time first. So I'm going to make a copy of the current time. Then I'm going to set the new time to be a minute in the future, and then I'm going to return the copy of the old time. Okay, so this is much simpler. This does everything that this one does, but also on top of it, I have to make a temporary time object, right? So postfix operators are actually a little bit slower than prefix operators. But let's make sure that this behaves the way it should. All right, so the int behavior was I changed it to 11, but I returned the old value of 10. And here I changed it to 26, but I returned the old value of 25. So that works there. Questions? Okay, let's finish this off by doing the decrement postfix as a global function. We also need a dummy parameter here to tell these two things apart. And then actually, this is probably the whatever. Return by value. So time t int dummy. Make a copy of t. The new time is t dot convert to seconds minus 60 t dot set time and return the temporary time object. Okay, so that should work just fine. And let's make sure that it matches the int behavior. So for the int, the postfix decrement, it starts at 11. It decrements it, but it saves the old value, returns it. And then when I print it out again, it's at 10. And I get the same behavior here. The old value is 926. It gets saved into a temporary time object. The time is decremented, and I return the old time. So yeah, this all looks good. Of course, the big takeaway, other than you can use global or member functions, but of course the dummy variable for the postfix. Again, it's an int, you're free to use it, but of course, probably you don't need it. But questions? Okay, that brings us to, this is just a review of the syntax. You can read it. I'm going to skip it. And let's go to, well, a lot of this class has been focused on memory management, right? Because in C++, that's kind of, a lot of your extra work goes to managing memory. But that can give you a good boost, right? Because memory is slow. So if you just manage memory in certain places, then you can really sort of optimize your program. However, when you get out in the real world, you're probably not going to do any raw pointers. Like that's so very rare these days. So what you're going to use is like a unique pointer or a reference counting pointer. And what those things do is, like Java, once they go out of scope, they just delete, they release the memory. Okay, so, but you still, even when you have automatic memory management, it's still good to know how it works, because when you need to optimize, you need to know that, hey, like when this pointer goes out of scope, it's going to free that memory, but that's fine, but it takes a long time. Like in CPU cycles, it takes a long time. Allocating and knowing when memory allocation and deletion happens can be very useful. All right, but what we're going to do is we're going to make smart pointers and reference counting pointers. And how we're going to do that is we're going to make a class, but we're going to have that class behave as a pointer. And to do that, we're going to overload these operators. This guy, not so much. We'll just ignore him for now, right? That should return a double pointer, but who cares? So we're going to make a class that behaves like a pointer, we need the arrow and the dereference primarily. There are rules for this arrow operator, and the rule is this function has to return something. The thing that it returns must have overloaded the arrow operator or be a pointer, right? So a pointer technically overloads the arrow operator, right? That's one of the functions for a pointer, is I just follow it's like a dereference and a dot in the same step. So we're gonna have to obey those rules, but otherwise, let's make a smart pointer. Oh, is it yeah, it's up here. Forgot to update this. All right, that's okay. Actually, let's change this up a little bit. Okay, so I'm going to make a new time object. I'm going to assign that to this time pointer, and then I'm going to do some pointer stuff with it, right? So what can I do with it? I can dereference it and send it to, now I have a time object. I can send that to the standard output because I've overloaded this operator. Or I can call the print function directly. I've modified the print function so it takes a stream object here, but otherwise it works the same as any other print. But since this is a pointer, I use the arrow operator. All right, so let's just take a look at that, make sure it's working. Looks good. I just printed it two different ways, one with the dereference, the other with the arrow operator. Maybe I could stand to have an end line there, but all right, there we go. So we printed out the time twice. So now what I want is I want to make of course I have a memory leak because I didn't delete it, but we're going to solve that problem by just using a smart pointer. So basically we want our smart pointer to behave exactly as a pointer does, so all of this stuff should still work, right? So that's our goal, and it's actually quite simple to do. Let's do it from scratch though. And then we could talk a little bit about reference counting pointers, which is already implemented. So for my smart pointer, well, let's see what we want. The first thing is I want to assign it a new time pointer. Okay, so this is going to make a call to the constructor. So my constructor should take a single argument, which is a pointer to a time object. Okay, and then, well, we want to keep a reference to that time pointer. So let's make a member that is t, and then I'm going to do everything in the header file. So I'm just going to assign this t to my member variable. And that should give us, this first line should now work. These other ones, not so much, but we can sort of verify. Yeah, it works. It's not going to print anything, but okay. Let's do this one next. Dereference operator. That should return. Well, in this case, I want it to return a time object. That's what the pointer did, and that's what we want. So time by reference operator dereference takes no arguments. Well, easy. I have a pointer to a time object. If I dereference it, I get back the time object, right? So I'm just forwarding this call to the same call made on my actual pointer. So let's make sure. Let's see if we can print. Well, there we go. There's our time object printed through our smart pointer class. Now we want to do the arrow operator. The arrow operator should return something that overloads the arrow operator. In this case, a pointer will do. Again, no parameters, so we just return t. T is a pointer to a time object, and then this should print a second time. So there we go. So now we have a class called Smart Pointer that behaves, in basically some of the fundamental ways the same as a pointer. We can't do a double pointer at this time, but we would have to maybe consider very carefully what we would want that to do. of course, I still have a memory leak, right? I haven't actually addressed the problem I was trying to address, which was when this smart pointer goes out of scope, I want this time object to be deleted. And so I can just write the constructor or the destructor for that. Okay. This should still work. Works fine. If I run it with Valgrind, yeah, I didn't actually call delete anywhere in my main function. I just made a smart pointer to a time object. I used it, and then I forgot about it, and it was fine, right? Once we exited that function, the smart pointer destructor was called, and that time object got deleted. And that's so these are quite simple, really. Questions? Okay, so that sort of follows that resource acquisition is initialization pattern where every time we allocate a piece of dynamic memory, we tie it to the lifetime of a piece of statically allocated object. And statically allocated objects are cleaned up automatically. Okay. What about a reference counting pointer? How much time we got? 10 minutes? Yeah, we can kind of go over. So, well, let's again. Well, our reference counting pointer should still do these things. But in addition to that, I want to be able to change that to RP. I want to be able to do this. I want to be able to have other things point to that same time object. And then I do not want that time object deleted until every single reference goes out of scope, right? This is basically how Java works. For Java, every time you have a pointer to an object, that is one reference to it. And if you have two pointers to it, there's two references, and it keeps track. And then eventually, once all the references go out of scope, then that gets cleaned up by the garbage collector. So we want a similar thing to happen here. Once RP, RP2, and RP3 all get destroyed, we want to delete that time object. Okay, so how do we do that? Well, it's already written, but let's talk about the sort of the model behind it. So for this, we have our heap. We have a time object. And then we have a reference counting pointer pointing to it. Maybe we have two of them. Right? And then at some point, one of these pointers goes out of scope. But at that point, I don't want to delete the time object. I want to just keep track. I want to say, oh, there's only one left. And then if this one also goes out of scope, well, at that point, I want to delete this time object. Okay, but only at the point where all of them are gone. So what I need is I need to share a value between all of these reference counting pointers that keeps track of how many of them there are in existence. And so to do that, we're going to add on the heap an int, and then those reference counting pointers will also point to that int. And this int will keep track. So in this case, it'll have the value 2. If this reference counting pointer goes out of scope before it gets destroyed in its destructor, it's going to decrement this. And then it's going to check to see, is that equal to 0? Well, no. Well, then fine. I'm just going to leave it because I know somebody else is still pointing to it. When this one goes out of scope, this decrements it to 0. And then this guy says, oh, I should delete both of these things. Right? So that's basically how they work. And so there is, I guess, one more detail. When I first initially make a reference counting pointer, I pass in a time pointer. Okay, so this is a constructor call. These are not constructor calls. These call the copy constructor. That's why that didn't work. Now, so yeah, anyway, that was a long time ago. Because it calls the copy constructor, not the constructor. So we would have had to put explicit on the copy constructor if you remember our conversation. If not, then don't worry about it. So yeah, these call the copy constructor. So in the copy constructor, I have a different job. Here, I have to make a new int to keep track of the number of references and assign this time object to my time variable. And I have a count. And so when I call the constructor, I'm going to make a new int and assign it the value 1. So I have one reference. Now when I make a copy of that, well, I want to point to the same time object, so I'm going to do that. I'm going to copy that. I want to point to the same count object, and then I'm going to increment that count object. So the second time I call this, now my count is at 2. And then the third time, the count is at 3, etc. And then I have to write a destructor. So the first thing I do is, I want to delete things maybe, but first I'm going to decrement the count, and then I'm going to check, should I delete everything? Well, if this new count is equal to 0, then yes, I delete all of the dynamic memory. If not, then I don't have to touch it. Okay? So that's sort of, it's a little more complicated, but not really once you work with it a little bit. The one thing we didn't do is the assignment operator, which is a little more complicated. Because the assignment operator, now I might be releasing a reference to this time object, and then now I'm acquiring a reference to this one. So I have to check, oh, do I need to delete this old one? And is this a new, you know what I mean? So there's a bit more to it, but in terms of a simple reference counting pointer, this should work. I mean, it doesn't do much, but let's do this. Let's just print it out using all of those, RP2 and RP3. No, it doesn't like that, eh? Oh, because I didn't even actually implement these. All right, there we go. All right, well, we printed it out a bunch of times, which is maybe not impressive, but there's no seg faults. That's a good sign. And we can try it with Valgrind. And no memory leaks, no double freeze. It seems our reference counting pointers work okay. All right, questions? All right, and that's really, there's not much to them, eh? That's basically what your smart pointers and reference counting pointers do in C++. Of course, there's, you know, maybe a few extra things for all of the possible edge cases. On your assignment, I know it says not to use smart pointers. If you want to use your own smart pointer or this one, feel free. Probably you want to use the version. When we take templates, we're going to actually make this into a templated version. So then you can make a smart pointer to anything. But yeah, you're allowed to use that in your assignment. All right, so questions? No? I do have office hours if anybody wants help with anything, but if not, have a good weekend and I'll see you next week. Technically, there's nothing due this week, so, but you know, you can still work on stuff.